Hello, my name is Simon Jordan from Cambridge Consultants. We've been doing a lot of work in wearable technology recently, and that always involves electronics. One of the problems with electronics is it's quite difficult to integrate with clothing. For one thing, you've got to take it out to wash it, and if it starts to get sweaty, it tends to corrode. Now, in an industrial environment, we get around that by using optical fibres, and there are lots of beautiful things using fibre optics with embedded gratings and expensive interrogators, but the problem is how to make that cheap enough to be a consumer product. And we've done two new things to make that possible. One is using plastic fibres, which are PMMA, and the other thing is we've reduced the cost and the complexity of the electronics to make it feasible to be a consumer application. And what we've chosen to do is to develop a new type of strain sensor. And the way that this works, if you can see the fibre here, this wiggle here, you can see that lighting up, and that's illuminated by a laser source which is in the box. The laser source is pulsed, so we're able to do time domain reflectometry. As the light travels down the fibre, it's scattered by bends in the fibre. If the fibre bends more, you get more scattering. And what we've done is we've set two time windows, two distance windows, and there's one here at the elbow and there's one here at the wrist. And this backscattered light travels back up the fibre, back into the interrogator. There's a directional coupler in there that's able to pick that off and send it into an avalanche photodiode. So if we look at the intensity against distance, we get two very dramatic peaks that come from these wiggles in the fibre. And from those intensities, we're able to judge how much that joint is bent. So what we're seeing here on screen is we're seeing the two intensities from these two time windows, the green and the blue. You see if I just touch the fibre slightly, you can see the blue one, the intensity changes. And if I touch the other one, you can see the intensity of the green one changes. Okay. Now in theory, as I bend the fibre, this will become brighter. The light actually leaves the fibre as well, but the light's too bright in here to show this. So I would have got into the suit, but it's too small for me, so I had to bring a wooden arm. But you see, as I bend at the elbow, the blue trace moves up and down, so it's able to detect the pose of the person who's wearing it. So if I bend the wrist, you'll see that this is able to move up and down as well. This is actually picked up on one of the main issues with this technology. This suit isn't really tight enough. You can imagine that if this moves around the joint, then it's picking up a different aspect of the motion of the person, and that makes it quite difficult to invert. And that means that this suit has to be absolutely skin tight. So there are many applications for this. We've had quite a few things come out at the conference today. People interested in taking it forward for monitoring patients or possibly for emergency responders to monitor respiration. But I think the general application of using plastic fibres in very low cost environments, a very low cost embodiment, I think that's really exciting for industrial applications, harsh environments, things where you can't get electricity and electrical connections easily.